All right, so now let's look at limit notation. So over here, I have this graph that you can see. We have this function that goes to negative infinity. Then it looks like we have a vertical asymptote. And then as we go to the right, it looks like it's like a little piecewise function, and then it just kind of trails off. So let's start with the limit as we go to negative infinity. So here we can see that as we're going down, we get to negative infinity, and it looks like the line y equals 0 is like a horizontal asymptote. So as we get closer and closer and closer to negative infinity, we're going to get closer and closer and closer to 0. So the way we would write this in limit notation would be lim as x approaches negative infinity of f of x is equal to 0. So to get the components down, this is what x is approaching. This is the function that you're evaluating the limit on. And then this is the value of that limit. So now let's continue. We see that as we go up, we have a discontinuity right here, a little hole, and then we keep going up. So let's evaluate the limit at that hole. First off, I'm going to evaluate the limit from the left. So the limit as x approaches -1 from the left will be written as -1 with a minus superscript. Think about it as coming from -1 from the left side is minus, -1 from the right side will be plus. So first, we're finding the limit as we approach -1 from the left side of f of x, and we can just see graphically that is going to equal to 5. Now let's do the same thing, but from the right. That would be written as limit as x approaches -1 from the positive side of f of x equals 5, and we can tell that graphically. Now, since both the left-hand limit and the right-hand limit match, we can join these together and say that the limit as x approaches -1, no superscripts, just -1, of f of x is equal to 5. Let's continue. As we go up and get closer to 0, we can see we're getting closer to 0. It looks like our function is flying to infinity. But on the other side, when we approach 0 from the right side, it's flying to negative infinity. So there is no limit that exists for limit x approaches 0 on its own. But we do have one-hand limits for this. Limit as x approaches 0 from the left-hand side, superscript negative sign, of f of x is equal to infinity, and then the limit as x approaches 0 from the positive side, the right side, of f of x is equal to negative infinity. Now, let's continue again. We want to find the limit as we approach x equals 1. Well, graphically, we can see that the left and the right-hand limit for that is going to be different. So we're going to have to split it up into two pieces, one from the left and one from the right. The limit as x approaches 1 from the negative side, the left side, is equal to -5. Ooh, and look, don't forget to put the function there. I forgot that. You'll get points taken off and you'll regret it. All right, and now we're going to do the same thing here. Limit as x approaches 1 from the positive side of f of x, and we can graphically tell that as we're approaching 1 from the right side, we get close to it. That's 5. All right, and now we have one last point we want to evaluate the limit at. The limit as x approaches 3. We can split it up into two parts, but you're looking at this graphically, so all you really need to see is that the limit as x approaches 3 of f of x is equal to 20. Even though the slope and the line is kind of like a straight turn, right turn, and it looks funky, these two pieces are still connected, and from both sides, when they approach 3, they are both equal to 20. Finally, we have this last limit here. As our function goes to infinity, we have an arrow that's just pointing down, meaning that it's just going to keep going straight in that downward direction, which means that our limit as x approaches infinity for f of x is equal to negative infinity. There you go. That's some examples of notation for left hand, right hand, one side, and altogether limits.